Okay, so what is symmetric encryption? It's basically one of the two modes of encryption that we're going to be talking about here. So symmetry, normally means that you have something that has some sort of two sides that are the same. So if we had this nice smiley face, right, we could draw a line of symmetry down the center and say these two sides are symmetrical here and here. And so like that, we'll say in encryption, we have a symmetrical encryption. Not necessarily when the encryption itself is the same, but when it uses the same key. So if the data that's encrypted uses the same key as the data, to encrypt the data, uses the same key as to decrypt the data, we have symmetric encryption. So that's the real key part. The same key can perform both the encryption and decryption operation. Actually, the algorithms in many cases can be the same. We'll look at a few modes in a later part where it's the same encryption and decryption algorithm. Or they can be kind of mirrors of each other, but this isn't a requirement of symmetric. So we say it's symmetric encryption because of the key being the same. So that's the most important one when we define different types of encryption. Downsides of symmetric encryption, so both sides need to know that secret key, right? So for this to work, because the key is the same, it's impossible to theoretically determine which side encrypted a message. So if we look back at this diagram, right, this key that the receiver knows is the same key that the transmitter knows. So the receiver could make a new message, right, and claim it came from the sender if all we're using is encryption, and there's no way to tell because both sides have that key and both sides are capable of encrypting and decrypting data. The other obvious thing is you need a secure channel to transmit that key in the first place, right? So we need a way to transmit the key because both sides need to have the key. So if you had a secure channel already, then presumably you have some form of encryption or security set up. So that's the two main downsides of it. The big advantage is that it's generally incredibly fast, right? So, and this comes down to some of the design of the algorithms themselves and requirements around it. So think if you want to, encrypt or decrypt your hard drive, right? You need a very fast encryption because you don't want to slow down your computer just to run the encryption algorithm. And this sort of goes back to this point that you need a secure channel already. The nice thing is that secure channel might be really low bandwidth. So say you were trying to send your computer hard drive, like a large file to a friend, and you could call them on the phone and you're pretty sure this is a secure channel, right? You could argue if that's the case or not, or you could meet them in person, and you could give them a small key. So, like 16 bytes, 16 characters of data, you could tell them really easily. But then over an unsecure channel, you can transmit gigabytes of data. So that's the idea of symmetric encryption, is that it's very, very fast. So we assume there's some other way to share the key, and that other way might be really slow. It's not suitable for sending all of the data. But we can use symmetric encryption to then send all of our data. It also tends to be fairly small, so compared to asymmetric and other ones we'll talk about later, it's a lot smaller, so that's the advantage there. So many symmetric encryptions are block ciphers. There's sort of two forms of symmetric encryption we'll see. When we say they're a block cipher, this means they work on a fixed block of data. So it's a size that's, say, 16 bytes of data at a time that it processes. If you need to encrypt more than 16 bytes, that's not a lot of data. If you need to encrypt a gigabyte, well, you just keep running it 16 bytes at a time, and you just chunk up that data until you've run it enough that it's now seen all of the data. If you don't have exactly 16 bytes on the last chunk, you have to pad it, so you add a little bit of data on. So this pad makes it be 16 byte multiple. So that the algorithm will work, right? And then, so if we padded it, we could then split up into the data and then pass it through the algorithm. The other thing we can see is a stream cipher. So a stream cipher, basically, you can consider that it works by encrypting a byte at a time. So as the data is coming, it's encrypting the data or decrypting it. there's no maximum, there's no block size. You can encrypt 5 bytes, 200 bytes, 201 bytes, 202 bytes. Most of the time how this works in practice is that they generate a key stream, and that key stream is basically XOR'd. So if we have a key stream here, it gets XOR'd in with our data stream. And then we have our ciphertext. So this is basically how all of our systems will work. So as an example, here's RC4. Is one particular popular form of stream cipher. And so what you have is you have some structure here, and there's normally some sort of feedback loop or something like this by design. And it's outputting this K is a key stream. So, every time through, it's generating a new portion of the key stream. Obviously, by design, these algorithms are, it's very hard. If you just see part of the key stream, it's designed to be incredibly hard to figure out what the next byte is. So if you've seen all of the previous key data, you shouldn't be able to predict what future key stream bytes will be. So in general, any sort of symmetric algorithm will have a few specifications. So we're going to look at one popular symmetric algorithm next. You'll have to decide what is, so if it's a block cipher, what's the block size, right? So how many data bytes does it work with at a time? And you also need to decide on the key size. So the key size is, again, dependent on the algorithm design. You might have like a 16-byte key. You might have a 32-byte key or things like that. No, most of the time, these key sizes are specified in bits. So when you hear AES 128, this doesn't mean 128 bytes. This means 128 bits. So the keys are almost universally described in bit sizes, right? So 128 bits is 16 bytes. So just keep an eye out for that. Because you're probably more used to seeing sizes of things specified in bytes, because that's more common, in other areas of computers. The implementation could also tell you some information about how fast it is. So this will depend on the design of the actual implementation. It's not specific to the algorithm, but we could have how many bytes are encrypted, say, per clock cycle, or how many megabytes per second are encrypted. These are related, so an algorithm that encrypts more data on every clock cycle of the device is obviously going to encrypt in total more megabytes per second. So as a simple example here, I give you, let's say you have an algorithm that is using a 16-byte block size. So again, we always operate on a block at a time. And to do that whole block, it takes 300 clock cycles of whatever this microcontroller is. So if you say, 16 bytes, right, over 300 cycles, this would give us this 0.0533 bytes per cycle. Even though we need 16 bytes always, we're still specifying it in bytes per cycle. We could then say, if the device runs at 200 megahertz, and assuming that means 200 million cycles per second, or million instructions per second, you could see you had a throughput of about 10.7 megabytes per second in this case. So you can sort of run some of these calculations to get an idea for what the performance of these different algorithms are. So as I said, what we're going to look at next is a specific version of the symmetric key algorithm called AES. The most important thing to remember, so if you forgot everything else already, that an algorithm is symmetric if the same key is used for encryption and decryption. Other ones you might run across, so if you see these algorithms listed, you'll know they're also symmetric. DES and triple DES are an older algorithm now that's still used a little bit. Mostly it's been superseded by AES. And RC4 was just one of the examples of a stream cipher you could run across. So there's a few other ones out there. There's a few sort of more regional ones. So for SM4, for example, is popular in China. So this is one that was specified by the Chinese government. And there's a few other versions like that as well. And you'll see various other regional algorithms available. But yeah, so let's go ahead and take a look at some specific algorithms in the next section.